So welcome to Altis Consulting webinar for today. We're going to talk about automated data and analytics platform on AWS. My name is Guillaume Jaudouin. I'm the AWS Practice Lead at Altis. I've been with Altis for almost 9 years. I'm based in Sydney, and I'm joined today by Neha. Neha, I think you're on mute.
Sorry about that. Hi everyone, I'm Neha. I'm a managing consultant over at Altis. I've been with the company for over 5 years now and have quite a bit of experience in building and delivering data analytics platform projects using AWS. I'm happy to be here presenting our automated AWS data analytics platform with Guillaume. Hope you all enjoy the session.
Thanks, Neha. So today we're going to talk about briefly about Altis, what we do, what products and services we offer, and a few things that we're proud of. We are also going to go through our AWS experience. Then we move into the state of data and analytics, and that's going to be talking about what we used to do 5 to 10 years ago in that space and what we do today, and it will lead to understanding why automation and DevOps for data has become more and more important. And then we'll also talk about the Altis AWS Serverless Data Framework that Altis has built over different projects and over the years and accumulating different experience. So about Altis, Altis is a data and analytics consulting company who was founded 20 years ago here in Sydney. We've got offices in Sydney, Brisbane, Melbourne, Canberra, Auckland, and London. We also have a managed services office in Auckland. We are vendor independent, which means that we're not in the business of reselling licenses. We're in the business of delivering successful projects for our customers to drive business outcomes. We've got around 115 staff around these offices, and we are delivering different products and services, as I said, around the data and analytics space. So you can see at the top, our goal is to turn your raw data from within your organization or outside of public data and transform this data, make it information, make it in a format that is consumable by the end users, and to drive decision and drive business outcomes for the organization. So in the data space, we work a lot with big data technologies. We work a lot in the different clouds, especially with AWS. We do in the information space, deliver visualization dashboards to understand the data, all the way to more advanced analytics with predictive analytics, machine learning, and prescriptive analytics as well. So we intervene at different levels depending on where you are in your journey. We can intervene at advisory, delivery, or managed services level. So advisory is more when you need to build your roadmap for data and analytics. So we can help you with the architecture of it. We can help you with the definition of future state. The delivery is the actual delivery of the data platform, so the build, development, testing, and so on of your data and analytics platform, and then we can support it via our managed services, things based in New Zealand, in Auckland. Supporting all of this, we have many data governance, different framework for data governance, for program management, and we make sure that knowledge sharing always happens when we deliver our projects, so we can all, as a company, as an organization, benefit from past project delivery. And we live by our ethos of connecting with courage, heart, and insight. A few things that we are pretty proud of at Altis. The first one is that we've achieved last year 10 years in a row in the Great Place to Work in Australia. That means that we look after our staff. We look after and our staff then in turn look after our customers and make sure that they deliver quality work in the projects that they're involved in. So that's really much happy staff driving happy customers sort of chain. And then we have also obtained this year, we've been endorsed for Work 180 and others as a preferred employer for women, which means that we empower women within our organization to achieve and grow within their career and thrive at Altis. More about our AWS experience more specifically. So you may have noticed we are vendor independent, but that doesn't mean that we don't work very closely with vendors. A good example of that is with AWS. We've had relationship with AWS, very tight relationship for the past 5 years. We've become a partner in 2015, and we've achieved the advanced consulting partner level since then. We also have a lot of certified staff in all our offices, mostly around solution architecture, big data, and DevOps space. And we also have a few individuals being recognized as Cloud Warrior and APN Ambassador in the past as well. From a service delivery perspective, we've achieved 4 accreditations for specific services within the AWS stack. They are for Redshift, Amazon EMR, Lambda, and Kinesis. So to give you a bit of perspective, this is accreditations that are given by AWS when you show that you have delivered multiple projects in production using those services and applying best practices when you use these services. We were the first in Australia and New Zealand to obtain the one for Redshift and EMR, and certainly across those 4, we have a pretty unique offering here. We are going to discuss now the state of data and analytics, and we're going to do it by seeing how it looked like 5 to 10 years ago, and how it changed and become and how the landscape changed, and where we've ended up today. So 5 to 10 years ago, you would ingest data probably coming from a relational database. It could be an ERP, it could be a CRM. You would ingest the data into a data platform. Most likely it will be a data warehouse, again, a relational table. From there, you will transform using an ETL tool and consume it, most likely using an enterprise BI portal. So you would very likely be using just the one vendor to do that, maybe a couple, but you pretty much choose the vendor, and then really the architecture was sort of chosen for you at this stage. You would normally develop within this platform using an ETL tool in a very manual way. So you'd have, for example, if you need to import 10 tables into your data warehouse, then that means that you build 10 different jobs to bring in 10 different tables and land that into your data warehouse. And then, as I said, the source very likely to be structured data. You live in a data warehouse, again, relational database, and what you do there is very much SQL transformation all the way. Today, we still have to ingest, transform, and store and consume the data. We still bring in data from relational database, but what has changed as well is that we bring unstructured data such as images, video, sound, then we bring in social media data that brings a lot of volume potentially, and a different way to work with the data. And also we work with IoT and streaming data, which means that there is a constant influx of data coming into your data platform potentially. So here you can see very different data types coming in and very different ways to deal with this data. From a consumption perspective, you still have your business intelligence use case, but now you also have data scientists that want to have access to your data. You want to be able to do data explorations. You open up your platforms to self-service potentially. You also have non-human usage of the platform, so you can open your data platform for API calls and integrate with other downstream systems you've got automation, decision automation happening as well, where you actually have a decision made without any human intervention. So here you can see that both on the data type side, so data sources and volumes and types and velocity, and on the usage perspective, we've evolved quite a bit in the last 5 years. So in order to cover that, you've got different ways to do ingestion. You can work with different data types. JSON, when you do API call, is very common. You can use the Kafka framework as well to stream data into your platform. From a transform perspective, you can still use SQL, but you've got also Hadoop-based frameworks such as Spark, and you can have Python, which is a very popular language to transform data these days. On the storage perspective, you still have your SQL data warehouse around, but you also have other file formats or other data storage options as well, such as Parquet. That's become quite popular when building data lakes, for example. On the consumer side perspective, you can still access your data with your traditional ODBC connections, but there are also other frameworks available now, such as Presto or Hive, where you can actually access files that, for example, are data stored in Parquet directly without the need to have it on in a relational database. So here, what the message is that there's been an explosion on both usage and data types and volumes of data, and the technology available as well makes the architectural landscape a bit more complicated, quite cluttered, and that complexity means that you can't rely on manual development anymore to deliver your data platform. So this is where I hand over to Neha, and she's going to talk to you about how automation is stepping into the world of data to help deliver this kind of platform. So over to you, Neha.
Thanks, Guillaume. Yep, so talking about automation in data analytics, there was a recent survey released of over 23,000 data professionals that found that they spend about 40% of their time gathering and cleaning data, 20% of their time building and selecting models, and only 11% of their time finding insights and communicating them to their stakeholders. This is something I believe is quite familiar to all of us, and more than ever before, now is the time we realize and understand the value of automating manual development processes for data consumption, integration, and discovery. Enabling users to spend more time on innovation rather than spending time on manual repeatable processes not only reduces the overall project delivery life cycle time, but it also increases productivity. The benefits of automating the iterative life cycle of the architecture and enabling the reusability of ingestion pipelines can also help businesses operate on a more continuous and agile process of project delivery. Talking about infrastructure as code, when we look at the overall life cycle of a data analytics platform project, automation doesn't need to just stop at the application development. Its benefits can be realized even more so when we extend it to automating the provisioning and management of the infrastructure that sits behind the development processes. Focusing on automating this repeatable and manual process can allow your data team to focus on building the data platform, gather the key insights, and enable you to make the key business decisions rather than spending time on maintaining the infrastructure and resources they require. Compare this to the traditional IT infrastructure, where it meant users would be expected to set up the hardware, servers, and networks, to manually perform these infrastructure deployments and write these custom scripts repeatedly for each environment to provision and deploy the infrastructure. Now, infrastructure as code allows users to treat infrastructure simply as code, where they can specify exactly the resources they need for the environment, save this code as a template that can be stored in a source control system and reused anytime to spin up a new or additional resources, or as well as a completely new environment altogether. Automating this process not only provides greater agility and scalability, but also cost efficiency for your team. Leveraging all these benefits that I just spoke about and bringing together the extensive experience Altis has in delivering data analytics platforms, we have developed a framework that fully automates the process of extracting, transforming, and loading the data into a single repository while reducing your cost of operations and time to value. This allows your end users to focus on the important task of data analysis and reporting. So basically, a key goal of the building this framework was to provide you with the performance, flexibility, and control to support the various rapid changes in your business needs that everyone goes through, and also help you grow this platform efficiently along with your business. To enable this, we had to ensure the solution was cost-effective, was easily scalable when it comes to compute and storage, was event-driven, and provided a fully managed ETL service, as well as provided faster and cost-efficient queries and a simple interactive querying interface for users. So when we talk about the key components of a data platform, these are the 5 main ones that we'll focus on. And these are the ones that help build the various functions of a modern data platform. So as Guillaume mentioned before, data ingestion, this is when you load and collect your raw data from multiple sources. Storage is where you reliably store your data in a secure and scalable platform. Data catalog, this is where your service creates a catalog of the data that is ingested using its metadata, including your schema, your location of the data. Data transformation, this is where your data is transformed from your raw state to the format that can be consumed by downstream services. Data analysis and querying, this is when the data has been transformed. It can be used by various BI tools or self-service manner by users to derive insights for their business. So just before I get into explaining the architecture of the framework, I'll briefly explain all their services that you see on the page right now. Amazon S3 is a service that we're using as a primary data storage. Given its scalability and high availability, we believe it's best suited as a single source of truth for your organizational data. DynamoDB that you see at the top is a fully managed NoSQL database service that provides us with low latency and high performance that we are using to store our metadata schema information. AWS Lambda is an event-driven AWS service which allows us to run code without provisioning or managing any servers. AWS Glue consists of 2 components, which is first is a Glue ETL, and the second is the Glue Data Catalog. Glue ETL is a fully managed pay-as-you-go ETL service, which under the hood uses Apache Spark as a distributed processing framework. Glue Data Catalog is a central repository for storing structural and operational metadata for all your data assets, such as schema, location, data format, and Glue ETL jobs use this metadata information from the data catalog. Amazon Athena that you see at the bottom is an interactive, seamless query service that's used to analyze data directly in S3 using standard SQL. Amazon SageMaker that you see at the end is a fully managed service that provides developers and data scientists with the ability to build, train, and deploy machine learning models quickly and seamlessly. So to begin with, something I want to highlight, when we speak to our clients, they come up with very specific requirements when it comes to the type of source systems that they use and the type of data they would like us to consume. This includes the data ingestion pattern, whether that's structured or unstructured data, batch or streaming, whether it's coming from a cloud source or an on-prem system. All these key factors often drive our decisions into selecting the most appropriate service when it comes to data ingestion. So whether that could be AWS Kinesis Data Firehose, data streams, or data sync. This framework allows for ingestion with any data integration service as long as the primary data store where the data can be stored is S3. In a similar way, how the curated data is used after it is stored in the presentation layer at the end can also vary from business to business, whether it's for reporting purposes using third-party tools, exposing the data to downstream systems, or having a dimensional model being built for data warehousing. All these use cases can help us extend this framework to meet your specific needs. Also, there are times when the exact use cases are not known to the business in advance, and this is where the framework provides that key flexibility, where you have this foundation of a data lake, where you can discover, explore, and analyze your data. And the insights and knowledge that you gain from these activities can then help you identify the exact use cases for your organizational data needs, where perhaps you may want to build a dimensional model in a data warehouse, build dashboards or reports for your key KPIs, or build machine learning models to derive insights and infer predictions for your business. The use cases are really wide and unlimited. So coming back to the architecture, as I mentioned, our framework uses S3 as a primary data store. At the high level, the first step is a file lands in the S3 bucket that you see at the beginning. Once the file lands, there is an event that gets triggered, which starts a Lambda function. This Lambda function tries to match the file schema with the information that we've already configured in a DynamoDB table. If this matches, then the Lambda function triggers a glue ETL job. If it doesn't match, then it's sent to a quarantine bucket. This is done to ensure that we don't send any poor quality or unexpected data for further processing. And the files in quarantine can be analyzed manually later on and fixed accordingly depending on your on how you want to handle data quality issues within your system. Next, the glue ETL job reads the CSV file and converts it into a Parquet format and stores it into the S3 staging bucket. The Parquet format allows for fast and cost-efficient queries. It then performs any transformation required on the staging file using Spark, and this could include any partitioning if required. And then it finally loads the data into the presentation S3 bucket. Once the data is available, the next step is to enable data discovery across Athena. This can be done by creating a create statement for each file against the database. And this allows the files to be registered by the Glue metadata catalog and queried using Athena console or any other query clients for analysis by end users. For users that are data scientists, we suggest using SageMaker as it provides a fully managed machine learning service with the ability to quickly build, train, and deploy ML models. This can be enabled by creating a development endpoint in AWS Glue and creating a SageMaker notebook to kickstart your ETL and machine learning scripts. In terms of automation, so how did we achieve this? We basically followed a metadata and event-driven approach that has allowed us to automate the key development processes in our framework. Right from the process of ingestion, events triggered on the S3 bucket when a file arrives removes the need for scheduling or pulling data from external systems. As soon as a file arrives, it can be consumed and processed for further analysis, saving time and development effort. Secondly, predefining and matching the schema upon reading each file ensures any non-conforming and poor quality data files are quarantined and not progressed through the data processing pipeline. Thirdly, using Athena, we can use the schema of the data set to automatically register each file that arrives in the Glue catalog. Lastly, using a metadata-driven approach, we can create a template Glue ETL job that can be used to populate the staging layer of the data lake. Out of the box, Glue ETL also allows us to auto-generate ETL code for transforming source data to target schemas. As highlighted earlier, by automating most of the heavy lifting involved with discovering, categorizing, cleaning, and enriching the data, we save cost as well as spend more time analyzing and discovering the data. When it comes to automating DevOps, we're using CloudFormation to create all the necessary resources, including S3 buckets, Lambda functions, IAM policies, the Glue ETL job, as well as a DynamoDB database. CloudFormation is an AWS service that allows us to describe and provision AWS infrastructure using a simple text file. CloudFormation templates can also be built and visualized using a drag and drop UI in AWS console and have helped us build a highly reliable and upgradable infrastructure to cater for not only the current requirements, but also future requirements. The framework also allows us to test these templates in advance to ensure that the chance for human error is minimized during deployments to production systems. And if there are any errors during deployment, the changes can be successfully rolled back, and earlier versions of the template can be used to restore the system to an earlier state. The code can also be designed to fail gracefully in the event of an unexpected error, like a service outage, and it can pick up where it left off to correctly complete all the tasks. To end with, as the data is extracted, transformed, and loaded into the presentation layer, we believe it is vital to ensure that data integrity and completeness is maintained throughout this process. For this reason, Altis provides a reconciliation framework that can integrate with any querying tool such as Athena to ensure that the data that is provided to the business is of high quality and can be trusted. This also allows the business users to focus on delivering the insights rather than focusing on identifying quality issues with the data. Some of the key functionalities that Altis provides in this framework are validation of correct business logic, checks for unique business keys, identification of null and missing records, as well as deleted records, default value checks. And this framework can also be easily extended to cater for your specific data quality and validation requirements. Over to you, Guillaume.
Thank you, Neha. So this ends the main part of the presentation. I would like to continue on with what we can do from here. What would be the next steps? So we think that here we can offer 3 different ways forward. We can either have a free workshop with your team to focus on your AWS data architecture and to discuss your current state and your future state of the data platform. We can also work on a proof of concept where we implement our AWS Data Lake framework using your data and establishing this way the foundations of the data platform with a possible production deployment in the future. Another way forward, depending where you are in your data journey, is a maturity assessment or a roadmap to cover things such as data architecture, data governance processes, data ops adoption within the organization. So, as I said, there's a few different ways we can progress from here. So feel free to reach out if you wanna discuss any of this. We've got a bit of time for questions, so I'm not too sure whether there are any questions. There is the Q&A option or the chat option in Zoom if you want to send through any question. We'll be sticking around for another 5 minutes to discuss if you have any question. If not, thank you very much for attending and be in touch if you want to discuss further any of this. All right, so if there is no question, I will end the session now. Thanks again for attending and hopefully we'll talk to you soon. Bye-bye.
Thanks, everyone. Bye.